Okay, today's lesson is talking about squares, and it's coming from 5-3A. The squares that we're talking about today are not necessarily the shape, the squares, although it does have something to do with that, but we're going to be talking about powers and exponents. Powers and exponents. And when we talk about powers in math, there is there's some vocabulary that we need to know. For instance, I'm just going to write down an expression, and we'll learn what this means in a minute. But how we would say this is 3 squared, okay? And this whole thing is called a power. The whole thing is called a power. Now, the 3, just the 3, is called a base, okay? The 3 is called the base, and the 2 is called the exponent. So an exponent is actually a part of a power, okay? So the whole thing is called the power, the 3 is called the base, and the 2 is called the exponent. And how you would read this, I'm just writing these things down for you to know. We would read this by saying, this is how you would read it. 3 squared, R-E-D. 3 squared, okay? Another way you could read this is 3 to the second power. You could also read it as 3 to the second power. So there's 2 different ways you can read it. You can say 3 squared, or you can say 3 to the second power. So when we use this term squared, and that's going to be the focus of the lesson today, when you use the term squared, it really means to the second power. Okay? Whenever you see the term squared, the exponent is going to be a 2. That's important to remember. Whenever you see the word squared, the exponent is going to be a 2. Okay? That's very important to remember. So let's do a few examples. Okay? If I have the multiplication expression 1 times 1, 1 times 1, I can write this as a power. That power would be 1 to the second power, okay? The number that you're multiplying is your base, and how many times you multiply it is your exponent. I have 2 1s here, so my exponent is 2, okay? So another example would be 3 times 3. The base is 3. I multiplied it 2 times. There are 2 3s here, so my exponent is going to be a 2. Okay? 5 times 5. The base is 5, and the exponent is 2. 6 times 6. The base is 6, and the exponent is 2. Notice the exponent is always 2 because I'm only multiplying it 2 times. That's important, okay? The exponent is how many times you're going to multiply that number, okay? So if I was to actually evaluate these powers, if I was to find out the actual value of each of these powers, 1 squared is 1 times 1, so that equals 1. 3 squared is 3 times 3, so that equals 9. 5 squared is 5 times 5, so that equals 25. 6 squared is 6 times 6, so that equals 36. Okay? So you see here, basically when you're trying to solve a power, all you're doing is multiplying. Okay? That's all you're going to do. The most common mistake when solving powers, I'm going to show you the most common mistake. Let's say you have 5 squared, 5 to the second power. If I ask you to solve 5 squared in your calculator or in your head, you should be doing 5 times 5. Why? The base is 5 and you're going to multiply it 2 times. So I put down 2 5s here to multiply against each other. 5 times 5 gives me 25. So 5 squared equals 25. That's correct. The most common mistake is when people see 5 squared, they do 5 times 2. This is incorrect. This does not equal each other. These two expressions do not equal each other. Okay? And then they put 10 as the answer to 5 squared. That is wrong. I'm telling you this because this is one of the most common mistakes, especially if you're rushing and you see 5 squared or 6 squared. You tend to do 6 times 2 or 5 times 2 because you know you're supposed to multiply, but they forget that you're not multiplying the base times the exponent. You're multiplying the base times itself however many times this exponent tells you to. Okay? So squares is pretty easy. We're going to go into other exponents later, but for right now we're just going to focus on squares, which is the exponent of 2. Okay? Okay, so now I want to talk about square roots. So let's erase this. Okay, so now we have square roots. So in math, we have what are called inverse operations, right? Inverse operations. Inverse operations, another word for that would be opposite operations. So for instance, if you have addition, the inverse operation to addition is subtraction. They're opposite operations. Okay? If you have multiplication, the inverse operation to multiplication is division. Okay? And now you're going to learn one more. If you have a square, and we know what a square is, right? A square is when you take a base and raise it to the second power. Anytime the exponent is 2, you're squaring that number. Okay, so that's the operation. The inverse of squaring is taking the square roots. And I'm even going to back that up some more because you're going to learn this later. Any exponent, an exponent is an operation, right? Because when you think of order of operations, you have parentheses, you have exponents, multiplication, division, addition, subtraction. Please excuse my dear Aunt Sally. Exponents is an operation. Okay, we're going to learn some about other exponents later, but for right now, we're only talking about squares. Every exponent has an inverse, and that inverse is called a root. And you'll learn more about that later. Every exponent has an inverse, and that inverse is called a root. Okay? For today, or for this lesson, we're going to focus on one exponent, which is the second power, the exponent 2, which is called squaring. And the inverse to that operation is the square root. Okay? So let's do some square root problems. Now, to show you what I mean by square root, I'm going to use an example. Say you have the number 5, and you do 5 and you add 6 to 5, right? You started off, let's do a different color here. You started off with 5 and you added the number 6 to 5. Now you have 11, right? How do you get back to 5? You have to do the inverse operation. What is the inverse operation? You add 6, so the inverse of that would be to subtract 6. See? These are inverse operations. And 11 minus 6 brings you back to 5. So you see what inverse operations do? They cancel each other out. So if you want to go back one step, you just do the opposite. You added 6 and got 11. So if you take away 6, you'll get back to 5. Makes sense, right? Okay, you can do the same thing with squaring and square roots. If you have the number 5 again, and you square it. We started off with the number 5, right? Let's get out of that light. No, you can't see. If you have the number 5, and you square it. Let's say you square this number, 5. Remember, square just means to have a 2 as your exponent. 2 is your exponent. If you square 5, what do you get? 5 squared equals, let's write it in red. 5 squared, if you say 10, you made that mistake. 5 squared equals 25. 5 times 5 is 25. How do I get back to 5? I have to do the opposite. So instead of squaring it, I need to square root. Okay? The opposite of squaring is taking the square root. What does a square root look like? Square root looks like this. It looks like a check with a division sign put together. Okay? It looks like a check mark with a division sign put together. That's the square root sign. I'll write it up here so you can see it a little better. This is what's called a square roots. Okay? It's like a check and a division sign put together. The square root of 25, when you're trying to solve this, that means, if I'm taking the square root of 25, that means what number can I multiply 2 times and get 25? Only one number does that. Oh, see, I just messed myself up. We'll talk about that in a minute, but there's actually 2 numbers that do that. But what's the obvious number that does that? 5. 5 times 5 gives you 25. So the square root of 25 is 5. Some people get this concept very easy. Some people struggle with it. So if you're struggling with it, don't feel bad. It's just something that you have to get used to. Okay? The square root is just another way of saying what number can I multiply 2 times to get this number underneath the square root sign. And that is 5. To get 25, I have to multiply 5 times 5 twice. Okay? And if you put it in your calculator, if you put 25 in your calculator and hit that square root sign, you're going to get 5. But it's important that you understand the concept because you're going to struggle in algebra if you don't get this concept. Okay? This square root sign, I keep saying it hoping that it'll click in your head. This square root sign, when they say what is the square root of 25, they want to know what number can I multiply 2 times and get 25. That's what they're asking you. What number goes here that will give me 25? It has to be the same number. Okay? What number can I multiply by itself to get 25? And that number is 5. 5 times 5 will give you 25. Hopefully that made it a little clearer. Okay? Now, the reason why I said I messed myself up is every square root actually has 2 answers. Okay? A positive and a negative. Why? Because negative 5 times negative 5 times negative 5 also equals 25, because negative times negative is positive, right? So that's always going to be like that. So every answer has a positive and a negative answer. So usually, unless they tell you they just want the positive answer, usually when you answer a square root question, this is how you would answer it. Okay? If they say, what is the square root of 25? That's your question. Your answer would be positive or negative 5. That's how you answer it. Okay? And how we say it is plus or minus 5. That's my answer. Plus or minus 5. You're saying it could be plus 5 or it could be minus 5. Positive 5 or negative 5. Either one of these numbers will give you 25 when you square it. Okay? And we prove that down here. So if I say, what's the square root of 4? What number can I multiply 2 times to get 4? Well, the answer is 2, right? But it's going to be plus or minus 2. It can be positive 2. It can be negative 2. Either one of those numbers, when you multiply them together, you get 4. Okay, let me just show that really quick. 2 times 2 equals 4. And negative 2 times negative 2 equals 4. So your answer is plus or minus 2 for the square root of 4. That's also important because your calculator doesn't do that for you. It doesn't give you the negative answer. It automatically assumes you want the positive answer. So you have to know that on your own. Okay? It's plus or minus 2. Let's see what other examples. I'll do another example. The square root of 36. And you'll get a lot of practice with these because it's important that you know these off the top of your head. What number can I multiply twice to get 36? What number can I multiply twice to get 36? Okay, you got to know your times tables. The number is 6. 6 times 6 is 36. So the square root of 36 equals plus or minus 6. It's either positive or negative 6. Either one is correct. Both are correct. Okay? So I think that's pretty much it for square root of whole numbers. You get more practice with this. The last thing I want to show you is square root with fractions.